Hello everyone, welcome to my YouTube channel. As you know, this channel is for SCSC Physics, and here in my channel you will get different videos related to SCSC Physics of class 8, 9 and 10. Today I am here with you to discuss about another topic, which is light. In this, I'll take one property of light which is called reflection of light. And in my video, discuss in detail about this reflection of light. Before going to the reflection of light, you must have to know what is light. Light is a form of energy. As you know, in physics, we are reading about matter and energy because physics is a branch of science which deals with the study of matter, energy, and the interrelation between them. So here, first thing to know, what is light? Light is a form of energy. Light gives us a sensation of vision. Light is that energy because of which we are able to see our surrounding. Means which part or which side or which source light will come to our eyes, from that side means to that object only we will able to visualize. So light is a form of energy which enables us to see the thing around us, or light is a form of energy which produces us in us the sensation of vision or sensation of sight. Or light is that form of energy by which we are able to visualize our surrounding. Next one, if we look, is the reflection of light. Reflection of light means whenever light rays coming from a source hit to any object, any reflecting surface, take the object or it take the light or return the light or bounce back the light to the same medium. That is called reflection of light. The bouncing back of light, the return back of light to the same medium. So reflection is the bouncing back of light or return back of light into the same medium by smooth surface or sometimes by rough surface. Whenever you are coming to the reflection of light, to understand better, we can take the example that when we take a tennis ball and will hit to the wall with certain amount of force, when a tennis ball hit to the wall, it can return back towards our side. So that is the reflection. The bouncing back, the return back is the reflection. And because of this reflection, we'll able to see the thing around us, we'll able to get the image of an object inside the polished surface. So this reflection of light again divided into some category depending upon the reflecting surface. First one is the regular reflection. Regular reflection means when the light is reflected from a smooth polished surface. Irregular reflection. Irregular or diffuse reflection means when the reflection takes place from a rough surface. Whereas multiple reflection. Multiple reflection means when two reflecting surfaces placed together with certain amount or certain angle between them, they reflect to form multiple image. So that is multiple reflection by a pair of media. So first one, here we are going to discuss what is regular reflection. Regular reflection is that reflection when a ray of light hit to the polished surface, smooth surface, and all the light rays incident parallel to each other to the reflecting surface, with all the incident ray with different points of incidence. Means point of incidence means the point where incident ray meet to the reflecting surface, and all the light rays reflect back from the polished surface with all these light rays parallel to each other. Means we will get a definite pattern of parallel incident ray and parallel reflected ray. So this type of reflection, the regular reflection, and regular reflection always form image, and this regular reflection will get from a mirror. What you can say is a mirror. Mirror is a glass piece in which one side is reflecting surface, whereas other side we have given a layer that may be of mercury oxide or any other material, so that will not allow the light to pass other side. So in case of a mirror, one side is coated with a uniform layer and other side it is a reflecting surface. So angle of incidence, angle of reflection will remain same and we'll get image from this regular reflection. When we'll come to irregular reflection, in case of irregular reflection, we'll get little bit different. So in case of irregular reflection or diffuse reflection, we'll get that all the light will hit to or non-polished surface or rough surface or uneven surface, so that light rays can go to any direction. Means here incident rays are parallel to each other, but reflected rays are not parallel. This is the reason they will not form any image, but advantage of this irregular reflection or diffuse reflection is that because of which we will able to see the object around us, or we will able to know about the any object in the corner, because light always travel in a straight line, which is called rectilinear propagation of light. But because of this diffuse reflection, it can go to every corner, so that it will be visible to us. So this is the irregular reflection which occur from a from a rough surface or uneven surface. Here, whenever we are coming to the reflection, we must have to know about some term used in a reflection. So here you can see one diagram, well-level diagram, where it is having all this term which is used in a reflection. First one, if we look, when a ray of light from any source, source means which is giving the light, from any source coming to the reflecting surface, this ray source to the reflecting surface, this ray is called incident ray. This ray is called incident ray. Means the angle at the ray which strike to the reflecting surface from the source is called incident ray. And when it will hit to the surface, when it will touch to the reflecting surface, then we'll get some more term. First one here is the point of incidence. Point of incidence means when any ray of light coming from a source strike the reflecting surface at a particular point. So here this O point is the point of incidence. And for reflection, point of incidence and point of reflection is same. Means in which point ray of light will incident on the polished surface or reflecting surface. From that point only reflection takes place. So next one is the normal. Normal means any perpendicular drawn to the reflecting surface from the point of incidence. So this ON is the normal here. Means a perpendicular or a normal or a 90-degree drawn from this point of incidence on the reflecting surface. The reflecting surface. So angle between incident ray and the normal, we can say angle of incidence. So here you can see the angle between incident ray and normal is called angle of incidence. The angle between incident ray and normal. So next, when it will hit to the reflecting surface, now reflection takes place. Means now the light will bounce back. Now the light will return back to the same medium. So that light rays which is coming from reflecting surface to outside, this is called reflected ray, or the ray what is obtained, what we will get after the reflection of light, that is called reflected ray. So reflected ray is the ray which is return back, turn back, or bounce back to the same medium. So here more one angle will get. Angle is angle between reflected ray and normal. The angle between reflected ray and normal is called angle of reflection. One is angle between normal and incident ray called angle of incidence. Angle AON here. Angle AON is the angle of incidence, whereas angle BON is the angle of reflection. So we'll get two angle of incidence, angle of reflection. Here you can see angle of incidence. Angle of incidence, the angle made by incident ray with the normal, or you can say the angle between incident ray and normal at the point of incidence. Whereas reflected ray, the angle between reflected ray and normal, or the angle made by reflected ray with the normal at the point of incidence. It is called angle of reflection. So one is angle of incidence, one is angle of reflection. So by taking these all points, we get two laws which is called laws of reflection. And in laws of reflection, we'll get two laws. One is the incident ray. Incident ray here, which one? This ray is the incident ray by making certain angle called angle of incidence I. And when it touch to the point of incidence, ray of light return back by making one angle R, angle of reflection, angle between normal and the reflected ray. So first law is the incident ray, reflected ray and the normal at the point of incidence to the reflecting surface all lies in the same plane, means this incident ray, normal and the reflected ray, where at the point of incidence all lies in the same plane, all the rays are on the same reflecting surface. Second one, the angle of incidence always equal to angle of reflection. That means this I is always equal to R, or we can say the angle made by incident ray with normal is always equal to the angle between normal and reflected ray. But when a ray of light strike the plane mirror, when a ray of light strike the reflecting surface in a straight path, in a straight line, or that time or perpendicular, that time we'll get lie rays too. When a ray of light striking the surface normally, in this ray of light now it is coming straight, coinciding with the normal, and we know the angle between normal and incident ray is called angle of incidence. But now incident ray and normal both are coinciding to each other. That means because both are coinciding to each other, the angle between them is 0 degree. As angle of incidence equal to 0, here we got angle of incidence equal to 0. So, and according to law of reflection, angle R also 0. So, I and R both 0 means light rays will come in a straight path, or light ray will come in which path strike the reflecting surface at the point of incidence and return back in the same path but in opposite direction. Path of reversibility means in which path will incident, the same path only to return back, but the direction is opposite. So angle of incidence 0 degree, angle of reflection 0 degree when a ray of light strike the reflecting surface in a straight line. Next one. Next is, if we look here, image of an object formed by a plane mirror. Plane mirror, what we are using in our home. Plane mirror, when the reflecting surface is flat, one side is having glass reflecting surface, whereas other side it is having a silver coating, mercury oxide coating, so it will not allow the light to pass outside. So if we will take one point source or point object, one dot, where the image will form. Let us discuss it. When you are taking a point source of object, here you can see a point source of object. This object, ray of light from O or object is striking to the mirror and return back, means we'll get the reflection. Second ray of light from the same object hitting to the reflecting surface, return back as the reflected ray. This one means first incident ray strike at C, going to CD. Second reflected ray striking to A and passing in the direction of AB. But both are equal loop, both are having certain gap. Means actually they will not meet. So they appears to meet at a point as a back side of mirror. It appears to us, it seems to us, we'll feel that they are having intersection point because they are actually not having any intersection point, or they will appears to meet at a certain point. This type of image form is called a virtual image. VIRTUAL, virtual image. Virtual image means the image which appears to form inside any reflecting surface. Real image means when both the reflected rays are having actual intersection point. Means actual image, real image, appears to meet virtual image. So when we observe or when we look from outside, it seems to us these light rays are having a meeting point, intersection point somewhere inside the mirror. So that point where both the reflected rays meet is called the image point. Image point means where the image form. So this is for a point object. But when we take any object other than this point object, then here you can see ray of light pass from here, the top, reflected back, more a set of light rays coming from the down, hitting to the reflecting surface, return back. So because both are not having any actual intersection point, so they appears to meet at a certain point here and here, up and down. So that it seems to us this is the image. But this image also having different characteristics. This image also having different properties that we will discuss later. So this is the image form for a point source, point object, or any other type of object will get from a plane mirror. Next one, it will come here. Image distance equal to object distance. Means the distance of the object from the mirror, means when you are standing before a mirror, your distance or your position from the mirror it will measure, that is the object distance, and where the image form from that image position to the mirror is the image distance. Object distance is the distance from object to mirror. Image distance is the distance from image to mirror, and for a plane mirror both are same. Here we'll prove that image distance is equal to object distance in case of a plane mirror. So let's prove this here. Given to us OA, this OA placed, because your A is the object which is placed at a certain distance from mirror, which is OA, and the image of this A object form at B, where OB is the image distance. So here we want to prove that OA equal to OB. First thing, a ray of light from A strike the mirror at C and return back. Means here one side will get incident ray, one side will get the reflected ray, and from D point we are observing to this A object. So a ray of light from A striking at C, return back to D, and this D point is the observer point. So from D, when the observer will see straight for this observer image at B, and we want to prove here O to B is equal to O to A. Here, let us take the perpendicular distance from A to B, a straight line. Because AB is a straight line and here CN is the straight line which is normal. So both are parallel to each other, and we know when two lines are parallel and one transversal line will get a set of angles here. AB parallel to CN. That means angle ACN. AB parallel to CN with the transversal line here AC. So we'll get the angle ACN equal to angle CAO. Angle CAO and angle ACN. Both are same. Both are equal because both are alternate angles. Because ACN angle equal to I. So the angle formed at vertex A, which is OAC, also I. When we take AB parallel to CN and BD as the transversal line, we'll get more two set of angles where angle DCN, angle DCN and angle CBO. Both are equal because both are corresponding angle. So we know that DCN equal to R, angle of reflection. So angle formed at vertex B, which is CBO, also R. And we know angle of incidence equal to angle of reflection. That means the angle formed at the vertex B equal to the angle formed at the vertex A. Means these two angles are same, and here again is a plane mirror. So the angle BOC and angle AOC both are 90 degree. Angle AOC and angle BOC both are 90 degree. Now we got the angle OAC equal to angle OBC and OC as the common side. So by taking the condition, the angle formed at the B vertex and A vertex is equal, and angle 1 and 2 means this angle BOC and AOC equal to 90 degree, whereas CO common side, this is the common side. So both these triangles are congruent to each other. COB triangle and COA triangle congruent to each other by the condition AAS, angle side. You read detail about the congruency in your math. We will get different condition when two triangles are congruent to each other. Congruent means exact same with each other. So because both are congruent to each other, here the side of COB triangle OB is equal to COA triangle OA equal to each other. That means OA equal to OB or OB equal to OA, because the corresponding sides of congruent triangles are congruent. Means when both the triangles are congruent, all the sides of first triangle is equal to second. All the angles of first triangle is equal to second triangle. So by this we can prove that image distance is always equal to object distance. Next one, it will come to the next part. In this we'll get that when a ray of light coming from any source hit to the reflecting surface, we will get a lateral inversion. Lateral inversion means left side seems to be right, right side seems to be left. You might have observed this one in the plane mirror also. In plane mirror, the object on in our right hand, it seems to us left hand, and object on the left hand, it seems to us right hand. So this is called lateral inversion. In lateral inversion effect produced by a plane mirror, it will reverse the object light to left, left to right, and this is the region that in ambulance is written laterally inverted. And lateral inversion in plane mirror, if we look, light to left, left to right only appear, but here will not get upside down. So image is not forming inverted, only the sidewise movement, means left seems to be right, right seems to be left. And in ambulance case, it is written laterally inverted, so that any vehicle moving ahead can see this ambulance who are laterally inverted and can give side. And also in English alphabet, some letters which is having lateral disc, which are having the effects of lateral inversion. Means when you keep that letters near the mirror, you write your name and you'll place near the mirror. Some letter you'll get remain same, but some letters will invert. So that is lateral inversion. Like some letters like A, O, it will take H. This type of letter are not having in lateral inversion. Whereas other letters like B, C, D, they are having lateral inversion. Next is the characteristics of image formed by a plane mirror. Means which type of image formed by a plane mirror. When you are standing near a mirror, if you observe, first one is to form the virtual image. Means they appears to be at a point. Second thing, it forms a straight image, erect image. Means body from feet to head, the same way we'll get inside the mirror. And one advantage of this plane mirror is size of object equal to size of image. Image and object size same. It is the region that plane mirror is usually looking mirror. Next one disadvantage is left seems to be right, right seems to be left, laterally inverted. And object distance equal to image distance means object to mirror and image to mirror distance is same. Means this mirror is used as a looking mirror because the size of object, size of image same, and it forms straight image and having some disadvantage that appears to be at a point, and left seems to be right and right seems to be left. When we'll take two mirror by making certain angle, we'll get multiple reflection. In multiple reflection, when a single image is form of an object and is placed in front of a mirror, one image, one object, one image. But what will happen if we use two or more mirror? Here we will discuss when we are taking two mirror. When we are taking two mirror, how many number of image will form that depending upon the angle between them. And with this formula is 360 by theta. 360 the total angle formed by a circle. Theta is the angle formed between two mirror. 360 by theta, 360 by that angle will take if it is odd, because always it form odd number of image. If 360 by theta is odd, like 72, 360 by 72 equal to 5. So no need to do minus. But if it is even, then 360 by theta is even. So that time like 90, 360 by 90 equal to 4. 4 minus 1, 3. Means always it form odd number of image. Because one in the first mirror, one in the second, or two in the first mirror, two in the second, and one in the joint part. For that you can always form the odd number of image. So 360 by theta, if it is odd, then that same number. If 360 by theta is even, then minus 1. Next, if we take a special case when two mirrors are placed parallel to each other by the angle between them 0 degree. But we are you will get this one barber shop. Here angle between them is 0. 360 by theta, 360 by 0, any number divided by 0 equal to infinity. That means when two mirrors are placed parallel to each other, a number of image will form. In first mirror some infinite number, in second mirror also infinite number, but in the plane mirror after each reflection some amount of light is absorbed. So because of that, intensity of light decrease, brightness of light decrease, that is the region that only will able to see some 5/7 image in each mirror. Because after each reflection, brightness of image gradually decrease, and it will come to that level when we will not able to visualize an image, then image formation will feel that stop, but actually they will form infinite number of image when it plays parallel to each other. If we take two mirror perpendicular to each other, means the angle between them is 90 degree. Now in 90-degree case, 360 by 90 is 4 and 4 is the odd number. Because 360 by 90 is 4, 4 minus 1 equal to 3. So 3 image will form. Means first image in the first mirror, second image in the second mirror, and third one nearly at the joint path. So when you are taking a pair of mirror, you can calculate the number of image form. Always form odd number of image. If 360 by the angle is odd, then no need to do any minus. If 360 by the angle is even, then we have to minus 1 to get the actual number of image formed by a pair of mirror. So this is about a plane mirror. So where we are using this plane mirror? What is the use of this plane mirror? As all of we know that plane mirror is the looking mirror in our dressing table in our home. Plane mirror also used in the shop or jewelry shop where we'll, when we want to buy any necklace or any chain or ring, we'll wear that one and we'll see in the plane mirror. It is also used in the trial room of different mall. It is used in the periscope and kaleidoscope. Periscope, which is used in the submarine to locate the or to know or to see the other submarines, and a kaleidoscope. Kaleidoscope, which is used for different design. We will able to observe different design inside the kaleidoscope. And plane mirror also used in a busy road so that driver can see the vehicles coming from the other side to prevent accident. And nowadays we are using for this purpose spherical mirror. So this is about the plane mirror. What is the use of plane mirror? What type of image formed by plane mirror? How it will form the image? And also reflection. In our second part, we'll discuss about the spherical mirror. Means when in plane mirror we got the reflecting surface flat, but if the reflecting surface a little bit curved, where the ray of light will go? What is the reflection? How the reflection occur in that mirror? So this all we are going to discuss in our second part.